Good morning and welcome to Algebra 1 Honors. Today we're going to go over the homework, which is graphing piecewise functions. So just take a look at the board behind me. Over here I have the first piecewise function that you had on your worksheet. I'm just going to graph that for you. What I said we need to do is look at each piece of the function and use the domain as an input to see what's happening. So I'm going to go over here and put a little bit of work on the board. I'm going to also move the camera over so you can see what I'm doing. Wouldn't that be nice? Here we go. Now, 2x plus 4 is the piece of the function we're going to evaluate first. And we're going to evaluate it, what happens at negative 5. So that's 2 times negative 5 plus 4, which is negative 10, plus 4, which is negative 6. So when I plug in a negative 5, I get out a negative 6. That's the first coordinate. So let's graph it with a solid dot, because that symbol was less than or equal to. So negative 5, negative 6, that's over here, solid dot. Where does it go from there? Now, remember what I said was when there aren't two endpoints, what we have to do is make another or use the slope, either which way. I know that this is supposed to be for x values less than or equal to negative 5, so it goes in this direction, whatever's happening to the left. I could use the slope, which was 2, and backtrack. 2 would usually mean up 2 over 1, but I can't go to the right, because it says x values only work on the left. So you could just, instead of going up 2 over 1, you could have gone down 2 to the left 1. This is where this line is going. So I'm going to draw a line with an arrowhead because it keeps going in that direction. If you wanted to choose a coordinate instead of using the slope, just choose a number that's less than negative 5. Don't go too far though, because as you can see, it's going down pretty fast. You want to use negative 6? Plug in negative 6. 2 times negative 6 plus 4. Negative 12 plus 4. Negative 8. So negative 6, negative 8, exactly where we were by using the slope. That takes care of the first portion. I'm going to erase this and then work on the next piece of my piecewise function. So we have 1/2 x minus 3. And I'm going to use that input, negative 5, to see what happens. So it's 1/2 of negative 5 minus 3. That's negative 2.5 minus 3. And that's negative 5.5. And that's fine. The coordinate we have here is negative 5, negative 5.5. With an open dot because it says greater than. So negative 5, negative 5.5 is right over here. It's just above the dot I already had. This one's an open dot though. And again, I can either use the slope to see where it goes, or I could plug in a number greater than negative 5. It's up to you. We can go up 1 over 2, up 1 over 2, no problem. Or you could plug in a number that's more than negative 5. How about 0? 0 is real easy to plug in, and it's definitely more than negative 5. If x is 0, half of 0 is 0 minus 3. Well, that's 0, negative 3. Which I also would have gotten to if I went up 1 over 2, up 1 over 2, up 1 over 2, okay? So, and I just need to connect it, and there we go. That's the graph of the first piecewise function. There's nothing else to do. All right, next up. G said the first piece is just negative 2 for any x less than 0. It's 3x minus 5 if x is between 0 and 3, and it's negative x plus 1 for x greater than 3. And again, you have this worksheet in front of you, so clearly you can see it. When it's just a number, it's actually kind of easy because that means that the y value will always be negative 2 for any x that's less than 0. So at 0, negative 2, I'm going to have an open dot. Why is it open? because it's just less than, not equal to. And it's going to be negative 2 for every value that's less than 0. So that is the first part of my piecewise function. I didn't even really need to do any math there because, again, it was just a constant. It's a horizontal line when x is 0, well, below 0. Okay? The next piece has an equation. We get 3x minus 5, and I'm going to plug in a 0 to see what happens, and then I'm going to plug in a 3 to see what happens. Because this piece of the function is defined between 0 and 3. So I'm plugging a 0 first. 3 times 0 minus 5 is negative 5. So that's the coordinate 0, negative 5. Less than or equal means it's a closed dot. So at 0, negative 5, I have a closed dot. It continues until x is 3. So I'm going to plug in 3 into the equation. So it's 3 times 3 minus 5. That's 9 minus 5, which is 4. So the coordinate 3, 4 is a closed dot on my graph. 3, 4, right there. I'm going to connect those two dots because it begins and ends the segment. Okay? And now I can move on to the next and last piece of my function, which is defined with the equation negative x plus 1. It happens starting at 3 with an open dot and continues for every x value greater than 3, so it continues to the right. Plug in a 3 and see what happens. Negative 3 plus 1 is negative 2. So at 3, we have a coordinate negative 2 with an open dot. 3, negative 2 is right there. Now where does it go? Well, it moves to the right at what slope? Negative 1. Down 1 over 1. So I'm going to go down 1 over 1, do it again, and we can make that line with an arrowhead continuing forever. If you'd rather plug in a number that's more than 3, you want to plug in 4. Negative 4 plus 1 is negative 3. So again, we're plugging in a number, 4. We get to negative 3. That's exactly where I was just by using the slope. Okay. Last one. The h of x function just had two pieces. Negative x plus 1 if x is less than negative 4, and 1/4 x if x is more than or equal to negative 4. Just two pieces. So again, I have my first piece, negative x plus 1. I'm going to use that domain value to see what happens at negative 4. So it's negative 4 plus 1. That's 4 plus 1, which is 5. So at negative 4, I have an output of 5. It's an open dot because it says less than. Negative 4, 5 is right over here. And where is it going to go? Well, it's a negative 1 slope. So you can either plug in a number that's lower than negative 4 and see what the output is, or you can use the slope backwards. Instead of going down 1 over 1, I'm going to go up 1 to the left 1 and do it again. I'm going to be in my writing, but whatever. Goes like that. If you weren't sure, what if you just plug in the number negative 6? Okay, negative 6 is 6 plus 1 is 7. We are going in the right place. And the last piece is 1/4 x, and negative 4 is the value to plug in there as well. 1/4 times negative 4 is negative 1. So at negative 4, we're at negative 1 with a filled-in dot. So negative 4, negative 1 is right here. And where does it go? Well, it goes up 1 over 4. That's the slope, up 1 over 4. We could just use that, go up 1 over 4. Up 1 over 4. And this will be a shallow line. It's a bad-looking line, but you get the drift. And that's the rest of the function. That's all there is. understand that when you graph a piecewise function, it has to pass the rule for functions, which means the vertical line test must pass. If you draw a vertical line through any of the ones we drew, they will always pass. And the place where it might hit twice, it doesn't, because one of them is an open dot, so it doesn't actually exist there. All right, so that was all you had to do for the homework. What I'd like you to do now is continue working on the piecewise practice worksheet number 2, which I've attached to the Google Classroom. Get that done, submit that to me today if possible, or by 7 a.m. tomorrow as usual. If you want a Google Meet, please email me and I will set one up if that is what you want. I'm not going to necessarily host it during the class period unless enough people actually want a Google Meet during the class period. It's fine if you do. Let me know. Send me an email and it won't be an issue. All right? Have any questions? Please let me know. Watch the videos. If you didn't watch yesterday or the day before, watch them. They'll instruct you as well. All right? Get the homework into me as soon as possible. Have a great day.